We're going to talk about our composite functions and building functions. Think of it this way. A function gives us a number, all right? And so if I have a function and I let x equal 2 and I plug that into one function and it spits out a number, let's say 5. And then I have another function and I plug 2 into it, and then that'll spit out another answer, and let's say that answer is 3. Well, I could add the 5 plus 3 and get 8, or I could add the two functions and plug in 2 and I should still get 8, right? So here are some rules about building functions and composite functions. And you might say, Mr. Adams, that seems kind of silly. Well, we don't use it necessarily to build functions. We use these rules and properties to break functions down into separate little more manageable functions, especially in calculus. And since this is a pre-calculus class, we need to learn about how to build a function so we can learn how to break it down. So if we let f and g be two functions with intersecting domains, then for all values of x in the intersection, the algebraic combination of g and f are defined by the following. So if I have a function f of x and a function g of x, if I add the two sums, it's the same as adding the equations together and then plugging in the value for x. We'll do some examples. Same with the difference. F minus g of x is the same as f of x minus g of x. Okay? Same with the product. F g of x is the same as f of x times g of x. And then the quotient rule is going to be f divided by g of x is the same as f of x divided by g of x. Remember, we can't have a 0 in the denominator, so we have to throw in there g of x cannot equal 0. So in each case, the domain of the new function consists of all numbers that belong to both the domain of f and the domain of g. As noted, the zeros in the denominator are excluded from the domain of the quotient. So in the final one, we've got to make sure that whatever g of x is, we got to find out what the zeros are and exclude those from the domain. Does that make sense? So what I want to do is we'll look at example number 1. Now, so for example number 1, they give us two functions. And we're going to apply those properties of those two that I just showed you guys on the screen here. Let me zoom in so you guys can see it. So for example number 1, we're given two functions, and I'm going to write these in different colors so that way we can keep track of what's going on. So let's let f of x, can you guys see that okay? F of x equals x squared, and let's let g of x equal the square root of x plus 1. And so what we're going to do is we're going to go through each of these. So the first thing that I want to write is f of f plus g of x. Well, this is the same as f of x plus g of x. Okay, which is the same as x squared plus the square root of x plus 1, right? That's it. My x looks a little funny. There's a little x in there. Okay? Now, if I wanted to do f minus g of x, I would say f of x minus g of x. Okay, and it's probably this isn't that confusing, this part. All right, so now for the next one, if I say f g of x, or f times g of x, that's the same as f of x minus g of x, or not minus, times g of x, which would be x squared times the square root of x plus 1. Okay? And then lastly, if I say f over g of x, that's the same of f of x over g of x. Now remember, g of x cannot equal 0, so we have to think about that later on, because we're going to come back and look at the domains of all these. Okay? And so this is just going to be x squared over the square root of x plus 1. And just for the fun of it, let's look at gg of x. Now how would I write that one? How about g of x times g of x? Which will be the square root of x plus 1 squared, which is just x plus 1, right? When you square a square root, you're left with the base. So what we want to do is we want to look at the domains of all three of these. All right? So let's look at the domain of the first one. Remember, there's a couple of different domain restrictions. One in particular is that we can't take the square root of a negative number. Here we have a square root. So when we talk about the domain of this, so if we look at, well, I should probably do this in black. If we look at f plus g of x, close, Mr. Adams. Yes. Okay. Okay. Bye. You need to go down to the media bay. Okay. All right. Sorry about that interruption. So f plus g of x is the function x squared plus the square root of x plus 1. Now the problem is that we can't take the square root of a negative number, so x plus 1 has to be greater than or equal to 0. So then x has to be greater than or equal to negative 1. So then the domain of this particular function is going to be negative 1 to positive infinity. And we're including the 1. Does that make sense? Yes, Mr. Adams. Let's move on to the next one. The next one is similar. If I look at f minus g of x, that is equal to x squared minus the square root of x plus 1. Again, you can't have a negative square root, or take the square root of a negative number is what I should say. And so, again, we have to consider that x plus 1 has to be greater than or equal to 0, so x has to be greater than or equal to negative 1. So then the domain of this function is negative 1 to infinity. We write the bracket. How come? Why do we write the bracket instead of the parentheses for the negative 1? Because we're including the negative 1, right? Because it can equal negative 1. Okay? Any questions so far? All right. Let's move on to the next one. Now, x squared can be all real numbers. I'm just skipping it for some odd reason, but I suppose I should consider it, right? It can be anything that you could think of. If I could plug in negative 10, negative 1, 0, positive 1. There's no domain restriction on the x squared term, or f of x, I should say. So now let's look at f times g of x. All right. So now if I plug in x squared times the square root of x plus 1, again, the issue here is we can't take the square root of a negative number, so then whatever x plus 1 is, it has to be greater than or equal to 0, or x has to be greater than or equal to negative 1. Again, the domain goes from negative 1 to positive infinity. We're including the negative 1 because of the equal sign, and that's pretty much it. Okay, last one. Well, not the last one. Two restrictions now. The restriction still deals with g of x. So when I say f divided by g of x, I get x squared all over the square root of x plus 1. Two restrictions. One is the square root of x plus 1 cannot equal 0. And the other one is x plus 1 has to be greater than or equal to 0 because I can't take the square root. Let's start with this first one. If I say x plus 1 cannot equal 0, our goal here is to solve for x. How do I get rid of this square root symbol? Square it. Whatever you do on one side, you do on the other. This becomes x plus 1 cannot equal, what's 0 squared out of curiosity? 0. X cannot equal negative 1. Okay, this is the second thing we have to consider. The second thing that we have to consider is that x plus 1 cannot be, it can't be a negative number, right? So I solve this and I get x has to be greater than or equal to negative 1. Now when you look at this and this, how do I determine, what do I write down for my domain? Well, before, we know that there's a negative 1 comma infinity. This says it can equal negative 1. This one says it cannot equal negative 1. So which one do we go with? Very good. We're just going to put the parentheses. That's it. Subtle change, but it's important. By just putting the parentheses, we're saying we can go right up to negative 1, but we cannot include it. So we have to make a decision. We have to use our noodles. We have to use our brains and make a decision. Algebraically, I get this answer. Algebraically, I get this answer. But this answer may give me a 0, and I can't have that. So this is step 1. This is step 2. Our final result is the domain is negative 1. Okay? And if we did the same for g of x squared, we'd go back to the original domain where we could include negative 1. Okay? So we really need to think about the function. We can graph it, but you know the graph is kind of hard to tell. The graph doesn't necessarily, when you look at your calculator, it doesn't really show you whether or not you can include one. I guess you could. I guess it does if you plug in a number. Like if you were to plug in the value for negative 1, it'll spit out a y value. In this particular case, you'll get an error, right? But sometimes you guys just graph it and you look at it and you go, oh, it looks like it goes to negative 1. But you gotta be able to prove that you either can or cannot include negative 1. Any questions on that so far?